All right, today we're going to be covering linear key features. It's really important that we understand this because we are going to be doing transformations, which means we're going to be taking linear functions and moving them around. We have to understand what the key features are so that we understand what making those changes does. So to start off, we have four key features, okay? The first one we have is the slope. Obviously, that's the steepness of the line. We have the y-intercept, which is where the line crosses the y-axis. We have the x-intercept, which is where the line crosses the x-axis, and we also call that a zero. And then we have the equation, generally written in y equals mx plus b format. Again, as we get to more function families, we'll see more key features, but for now, these are the four that we care about. All right, so let's start with slope. So first of all, we want our slope to be, we want to use integer, rise, and run, okay? So we don't want to be rising half, running one. We want to rise one, run two. Always be rising and running in integer values. So one of the things that I haven't really talked about doing, but that might help those of you who keep making mistakes with forgetting to say that it's negative slope, is you might want to try signing the line. So let's talk about what sign the line means. Okay, so sign the line means, like, I come down here to the bottom and I write my name, I sign my name, like as if I'm signing on top of that line. Whatever direction my name is going, I can see that my name is going uphill, so that's going to help me decide whether I have positive or negative slope. That's a way for me to help not make that mistake. And then once we've decided whether our slope is positive or negative, so in this case, my slope is positive, I'm going to actually find 2 points to rise and run along. I'm going to take a little, so we want rise or run, rise over run, or as I've been calling it also, vertical change over horizontal change to find the slope. So we're going to take a little detour right now because in a lot of cases, using the y-intercept and the x-intercept is going to be easiest for us to find that. So what is our y-intercept? Our y-intercept is where the line crosses the y-axis. Okay, and it always starts with a zero. So it will be 0, comma, a number. Okay, so our y-intercept is right there at the coordinate 0, comma, 6. So B is 0, 6. So again, that order pair is always going to start with 0. Now, the other point that we can, if we're able to, we want to use for our x-intercept, for our slope is our x-intercept. Now, we can't always use those 2 points, but if we can, we want to. So our x-intercept is where the line crosses the x-axis. Okay, and that one always ends with 0. So it will be a number, comma, 0 for its ordered pair. So we look for where it crosses the x-axis, and I can see right there at 4, 0 is where my line crosses the x-axis. Whoops, sorry about that. Okay? Now that I have those 2 points, I can use them to find my slope. So I'm going to rise. Remember, I count the spaces. A lot of you guys are counting the lines, but a lot of times when you do that, you accidentally count one extra line because you count the line you started out. So we're going to count the spaces. I have 1, 2, 3, 4, 5, 6 spaces. So it's going to be my rise. My rise is 6. And then my run is my horizontal change, which is 1, 2, 3, 4 spaces, 6 over 4, which simplifies to 3 over 2. And I know that's positive because I signed my line. All right. Now that I know what my let's take one really quick step back and talk about something about slope. So I want to remind you that with slope, it doesn't matter which points I go between. I'm always going to have should get the same slope. So for example, if instead of going from the x-intercept, from the x-intercept to the y-intercept, I went from the y-intercept to that point right there, that would take me up 3, right 2, still get 3 over 2. If I started all the way, if I started all the way down here and I went up all that and over here, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 10, which also reduces to 3 over 2. So it doesn't matter which 2 points I go between, I'm always going to wind up with the same slope. All right, so once I know M and I know B, I can use M and B to write my equation. And my equation is y equals mx plus b, which in this case is y equals 3/2 x plus 6. Okay, now I can find that same information by looking at a table. So for a table, I can actually find those key features. Now, 2 of them I can find, 1 of them I still have to calculate. But let's start with the 2 I can find, okay? So the first one I can find is my y-intercept. That's the row that starts with 0, okay? And then if I have a table in front of me, I'm going to label it B. So I look for the row that starts with 0. There it is. That's B. Okay. For my x-intercept, I'm going to look for the row that ends with 0. And I'm going to label that one Z. For 0. So I look, and here it is. I find the one that ends with 0, and I label it Z. Now, if I want to, I can use those 2 points. I can use any 2 points. I can use those 2 points. But let's be smart about it, okay? If I can use points, first of all, I'm gonna tend to go for points that have whole numbers in them. Like, I am not messing. I'm not trying to mess with decimals. Okay, I'm also going to try to avoid numbers with integers because, again, those are things I make mistakes with. I make mistakes with decimals, I make mistakes with integers, so I'm going to try to use the easiest points I can. So for me, I actually like these 2 points, okay? So how did I get from 9 to 6? I had to add 3. How did I get from 0 to 2? I had to add 2. So again, I'm using my delta y over delta x, or the slope formula if you prefer. And I can use, like I said, any 2 points. But just kind of be smart about it, okay? Avoid fractions, decimals, and negatives. Unless those things don't bother you. I'm like, can you even read that? No, nobody can. Can I erase, please? No. Negatives, okay? Now, of course, if you're feeling brave, go ahead and use your negatives. But if you're not, you don't have to, okay? So that would give me my delta y over delta x. We just said delta y is 3, delta x is 2, and 3 over 2 is my slope. I prefer to leave slope as a fraction, and generally do, because remember, slope is how I move. So if I'm up here and I make my slope 1.5, I'm going to have to go up 1.5, right 1. I don't want to do that. So we usually leave our slope as a fraction. But if you write it as 1.5 or 1.5, it's not wrong, it's just not what we do. Okay? So that's the first thing we need to understand. We need to understand these key features. So this is the key features from a graph, and here they are from a table. Now, the other thing we need to understand is what the linear parent function is, okay? Our linear parent function is the simplest linear function that we can write. Every function has a parent function. We're going to learn about linear, quadratic, and exponential functions, and we'll find parent functions for all three of them. And it's the simplest version that can be written. Every other function of that family is a variation of the parent function. So maybe we change the slope. So instead of, we change the slope or we change the y-intercept, and that makes it a slight variation. So our parent function is y equals x. We've talked about our parent function as having, we've talked about our invisibles. So if we wrote that with all the invisibles, it would be y equals positive, well, it would be 1x plus 0. And if we really wanted to write that correctly, we'd write it 1 over 1x plus 0, because we need a rise and a run, and we can turn any number into any number into a fraction by adding 1 below it. Now in function notation, all we would do is change y to f of x. So it will be f of x equals x. So when I look at the linear parent function, the linear parent function, every x is the same as y because y equals x. So if I put in -2 for x, I get -2 for y. If I put in 0 for x, I get 0 for y. If I put in the square root of 17 for x, I get the square root of 17 for y. If I put in -4/7 for x, -4/7 for y. If I put in pi for x, I'm going to get out pi for y, okay? So whatever I put in for x, I'm going to get the same thing out for y. So what would that look like? Well, we already said that that 0, 0 works. We said that -2, -2 works. If I put in a 3 for x, that means y is 3 also. If I put in a 7 for x, that means y is 7 also. If I put in a -7 for x, y is -7 also. So just give me grace on this line that I'm about to draw. Oh, well, that's not bad. Oh, don't judge me. It's because I put that one in the wrong place. Oh my gosh. Hold on, let me erase this. 7, 7. Okay, you know what? It's not your first day in my class. You know this kind of stuff happens. Okay, so here's my line. Pretend that line is straight and not all squiggly. That is our linear parent function. So here's a couple things we're going to notice about it. Number 1, m is 1, b is 0, and it is proportional, which means it's also direct variation. Okay, and like I just said, whoopsie, whatever x is, y is the same, and it bisects quadrant 1 and quadrant 3. Remember, our quadrants go 1, 2, 3, 4 in the shape of a C. And bisect means cuts in half, perfectly in half. So assuming this line was actually straight and not written, whatever. The quadrant 1 is cut perfectly in half along that diagonal, and so is quadrant 3. So the last thing is our domain and range. The domain and range of the linear parent function. We didn't really talk about this, and I will go into more detail about this, but since this is a line and it goes off forever in any direction, there's no limit to the x values I can put in for this function. And how we describe that is all real numbers. You can write that as ARN. You can use the math symbol for all real numbers, which is an R with an extra bar. But it's all real numbers, meaning I can put any real number in there. And don't worry about what non-real numbers are. Those are imaginary numbers, and that is your problem in Algebra 2. That's not our problem this year, okay? Well, if I can put all real numbers in for x, that means I can get all real numbers out for y. So this is my parent function. Again, it's the simplest version of the linear function that I can write. Any other equation is going to be me modifying the slope or modifying the y-intercept.